If you are following the news of AI, then the keyword explainable AI must not be a new concept for you. But what makes AI explainable? What are the tools? What are the platforms? What are the packages that help make AI explainable? One of those famous platforms or tools or packages is called SHAP, and that is what we are going to learn in this video. Very important, very critical for your data storytelling. Please ensure you watch till end. Let's try understanding SHAP with 5 key agenda. Okay. So first we are going to understand what is SHAP. Then we are going to understand how it works. Then we are going to understand what is the problem it is solving. Very, very important. After that, we are going to go directly into Python and do some hands-on. And then I'm going to leave you with some way forward or how you can use these learnings. Okay. First of all, guys, what is SHAP? So SHAP basically stands for Shapely Additive Explanations. Okay. So I will write here Shapely. Okay. Additive and explanation. Okay. So just remember this, and here from these initial keywords, right? SH, okay, and A and EXP explanation. So P, okay. From these three words, SHAP is made, okay. Shapely additive explanation. Now, what is SHAP and how it works? SHAP is basically a game theoretical approach. So this is an approach that was coined by a mathematician or a statistician known as Lloyd, Lloyd, Lloyd Shapley. Okay. By this person, there was a theory coined which is used behind how SHAP works. Okay. So what is this theory? We will first try to understand this. Suppose there is a game. Okay. And in that game, there are 3 players. For example, Aman. Okay. Aman is one player and Kumar is another player. Okay. And John is third player. So there is a game in which there are 3 players. When Aman plays that game alone, Aman wins $20. When Kumar plays that game alone, Kumar wins $30. When John plays that game alone, John wins $40. Okay. So these are their alone individual performances. This is scenario 1. Now, what happens if we start playing the game with a coalition of players? So please try to understand this critical concept here, guys. What happens if we start playing the coalitions? For example, what happens if Aman, okay, and Kumar, these 2 guys, play the game together? What happens if Kumar and John, these 2 guys, play together? What happens when Aman and John, these 2 guys, play together? What happens when Aman and Kumar and John, all these 3 guys, play together? So this is your one coalition, another coalition, another coalition, and another coalition. So I will start putting some rewards here. For example, when Aman and Kumar both play together, just for simplicity, understand that they make 60. Okay. When K and J, Kumar and John, plays together, for simplicity, just understand they make 80. When Aman and John plays together, for simplicity, let's think for a moment, they make 70. Okay. And when all 3 guys play together, for simplicity, let's say they make 100. Okay. So if you observe here carefully, guys, Aman is making 20 and Kumar is making 30. So if I add Aman's and Kumar's, that is 50. But here, when they play in coalition, they are earning 60. Okay. Which is 10 more. I will repeat it one more time. When these guys play individually, they earn 20 and 30 separately. But when they play together, they earn 60, which is 10 more than their combined individual performances. Okay. So there are 4 important concepts in this game theory. One is called players. Players you have already understood, all these guys. Then comes the concept of coalition. Okay. Coalition means I told you these are one coalition. Okay. Then comes the concept of value of coalition. Okay. So Value of correlation is nothing but the numbers I have written in front of them. And most important concept in this entire fundamental theory is called marginal correlation. Okay. So how marginal correlation is computed is, suppose Aman individually makes 20. What happens when Aman goes and gets added to Kumar? Okay. That is your marginal correlation. So Aman and Kumar individually 50. I mean, if they play individually, right? But when they play together 60. So the marginal correlation here is 10. So for all these sets, right? How many sets will be created here? One set, two set, three set, 4, 5, 6, 7. Okay. For all the combination of sets, right? This marginal correlation score will be computed for all the players. Okay. And these score will be averaged out, and that is nothing but their shape values. Okay. Shapely values for these guys. Now this was how the game is designed. Okay. But what you and me have to do is now replace these players with your model features. Okay. Model features. Replace these correlation with your feature combination. Feature combination. Okay. Combination. Replace this value of correlation is prediction. Okay. Prediction. And marginal correlation is, as we have understood, right? How much the prediction will change when we shift from one group to another group. Okay. Based on, we will compute for all these guys one by one. For A, we will compute. For B, we will compute. For C, we will compute all these players, all these features. Okay. That is your marginal correlation. So after this concept, right, let's try to understand in the machine learning point of view, how it will help and what is the problem statement it will solve. Suppose I'm building a linear regression model and I have two independent feature. One independent feature is experience in machine learning. Okay. Another independent feature is experience in Python. Okay. And the target variable is basically salary. Please try to understand this, guys. This is my data. Okay. My first column is experience in machine learning. My second column is experience in Python for a candidate. My third column is salary column. Okay. And there is some data here. Okay. Imagine there is some data. You are training a regression model. You are trying to predict salary based on experience in machine learning and experience in Python. Now, if you say somebody's salary is 10,000. Okay. I want to know how much of this 10,000 is coming from this feature and how much of this 10,000 is coming from this feature. Okay. Please try to understand the difference here. If I fit a linear regression model, some of you might argue that coefficients will solve that problem. Then why SHAP, right? Let me tell you the difference. When you fit a linear regression model, right, what you are going to get is salary plus beta naught plus beta 1 experience in ML, correct? Plus beta 2 experience in Python, correct? You are going to get this equation. So you are dependent on beta naught, beta 1 and beta 2 to have any kind of explanation of your model. So suppose business is asking you how much experience in machine learning is impacting my salary. So what you can say, you can simply say keeping all other variable constant. If I increase experience in machine learning by 1 unit, my target shift by this much, something like that. Okay. That will be your explanation, but that is not what I'm looking for. There is a difference. What I'm looking for is, if I'm saying salary 10,000, then can you tell me that 6,000 is coming from experience in Python and 4,000 is coming from experience in machine learning? Can you give me that level of detail? And this problem is exactly what SHAP is solving. What SHAP will tell you is, out of this 10,000, okay, let's say 6,000 is my base value. So SHAP will start with a base value. Take this as a base value. Okay. On top of this base value, right, SHAP will either increase or decrease based on what is coming from other features. Now, in this case, what can happen is 2000 can come from experience in machine learning and 2000 can come from experience in Python. Okay. So this is your ML experience and this is your Python experience. Altogether, the prediction is a sum of base value plus individual SHAP values. Okay. This is called base value. This is called individual SHAP value for feature 1, individual SHAP value for feature 2. Okay. The problem statement which SHAP is solving is it tells you how your 10,000 is reaching. How it is different from linear regression is it does not give you that level of information. It simply tells you, okay, this is the coefficient, this is the change you can expect. Okay. So with that in mind, let's go ahead and try to do some Python demo. Okay. So let me go to Google Colab once. You have to install a package called SHAP. Okay. Pip install SHAP. You have to do that. After that, what you can do is you can simply import SHAP. Most of these are normal machine learning basic code. So I'm not going to write it, just going to show you and share with you. Okay. Import SHAP, import pandas, import numpy, import XGBoost, import linear regression, and one data to play around. Okay. Load diabetes, model selection, trend test split. Nothing fancy here. Diabetes is equal to this. This is up to here. There should not be any understanding problem. Okay. So diabetes data you are loading, you are separating trend and features and target, and then you are assigning feature names, then breaking, then training a XGB regressor. Okay. After that, whatever I'm highlighting here, please pay attention here. I'm saying calculate SHAP values, and I'm saying explainer is equal to SHAP.explainer. Give your model, give your training data. This line will give you an explainer object. Okay. And when you pass your X test to that explainer object, right, then it will give you the SHAP values for your X test. Okay. So I will show you what this SHAP value will contain. But here, when I run this entire thing, right, let me run it in front of you. When I run this entire thing, right, you will see that a beautiful chart is coming here. Let's try to understand what this chart is. Okay. But there are two lines here, sap.init.js that will just give you a JavaScript support for plotting this. And this is called a force plot. In this force plot, what I'm doing is for the first data point. Remember guys, what I'm trying to do is I'm trying to get the prediction for first data point. Okay. So I have X test, right? I have X test. In this X test, there could be many rows, right? Many data points, right? I want to get X, I want to analyze only one observation, and my observation is X test 0, the first observation that I'm analyzing. Okay. So what X test 0 should have, based on our previous learning, what X test 0 should have? It should have a base value and it should have a values from other prediction, from different features, right? So let me come here. What I'm expecting here, I'm expecting a base value. Okay. I'm expecting sum of all feature SHAP value. Okay. Sum of all feature SHAP values. Okay. And in the end, I'm expecting the final prediction for X test 0. Correct? I hope this is very clear to you now. There will be a base value. There will be sum of all feature SHAP value. And then if you add these two, right, first and second, you will get third. So let's try to see that. In this chart, right, if you see, first of all, let's try what I'm saying. Explainer.expected value. So expected value is nothing but your base value. Okay. And here I'm saying, give me the SHAP values for first observation. And here I'm saying, give me the data point of first observation and then feature names. Very simple. If you see here, the base value is 153.1. Let me start putting it here. Base value is equal to 153.1. Okay. And if you see, the final prediction is 183.56. So I'll write here 183.56. Okay. Which means that sum of all feature SHAP values should be a difference of these two. So let me see that. So in this chart, right, whatever you see red color, if you see here, right, I'm hovering my cursor. When I say higher on right hand side, it tells me what is increasing my value. Okay. And these blue ones, it says what is decreasing my value. So it starts from 151. So age is increasing, S5 is increasing, sex is increasing, S2 is increasing, but BMI is decreasing, S3 is decreasing, S1 is decreasing, S6 is decreasing. Don't confuse with these values, guys. These are your data point values. For example, sex is minus 0.04 is your data point value. Age is 0.04 is your data point value. Okay. Don't think this is a SHAP value. Okay. SHAP value I'm printing here. See here. Base value is equal to explainer dot expected value that I told you here. Okay. SHAP value for 0 will be, of course, many values for all the features. So I'm taking a sum here, and actual prediction, as I told you, will be base value plus SHAP sum. Okay. So if you see here, sum of SHAP value is 30.48. So if I put here 30.48, right? 30.48. And if you sum these two numbers, if you sum above two numbers, right, you are going to get the prediction. That is what the magic of SHAP. Okay. It tells you where from prediction is coming. So it started from 153.1. Then various features contributed in either increasing or decreasing, but finally it increased. It increased to where? It increased to 183.56. Okay. What contributed to increase? These guys, whichever is coming in red. Okay. What contributed to decrease? These guys, which are coming in blue. Okay. Whatever numbers you see, these are individual feature numbers, feature values. And then we have this. Now let's see what are the SHAP values for 0th, 0th data point, right? So if I run this, you will see that in SHAP values, these are the values. The base value, as I told you, is 153, and data point is what is showing here. Okay, data point is basically this. So see, for example, minus 0.04 is sex, so it is coming here. Similarly, BMI is minus 0.006, so this is coming here. So three things only: SHAP values, base values, and data points it is giving. And X test 0, if I want to see, this is basically your data point that I was telling you. So this value, okay, this value, I mean the bottom value, and this value will be same. Okay. So SAP values anyway we have calculated above, but if you do a summary plot, right, it will show you something like this. Well, it will tell you how at a model level, right, how at a entire X test level, how things are impacting the prediction. For example, S5 feature is impacting more spread out. Okay. BMI is spread out and things like that. So there are various kinds of plot that we can plot here. So I will also give you the link of documentation that is here. Okay. Welcome to SHAP documentation. And as I was telling you, right? So what it tells is a game theoretical approach to explain the outputs of any machine learning model. It connects optimal credit allocation with local explanation using the classic Shapley values from game theory and their related extension. Okay. So as you can see here, base rate is 0.1, output is 0.4 based on all these features. Okay. And this is called a waterfall chart. You can try this as well, whatever is showing on right hand side. So there are many charts. Okay. And here I have used one model, XGBoost model, right? You can use many models. I also tried with linear regression once. Okay. So obviously the prediction will vary for linear regression, right? So see, the prediction is 139 for linear regression. And if I run these things, right, it will vary. Everything will change. Okay. So you can change and you can try. That is one thing. But what I wanted to tell you is what you have to do by learning these things. Most important. Okay. I want to tell you one thing very, very honestly, guys. In the world of AI and in the world of deep advanced LLMs, right? Uh, more and more you become better in anything that has a humanly touch, right? It is better for you. That is what I am also learning. Hence, I am telling you. So, what is the thing which will have a humanly touch? The storytelling, the presentation, the message conveying, right? So, all of us have to learn the art of storytelling, conveying, presentation. How we will do that? We will do that using beautiful plots. Okay. So, these are all the plots that you can use in your SHAP. For example, I showed you one plot only. You can use all these plots and see how you can create a very nice story. But you'll have to agree with me that if you show this chart and if you explain to business, right, they will be impressed. Okay. And that is what my intention of this video, guys. Please go and read more about SHAP, read more about model explainability, read more about how things are shaping up in the industry, read more about what skills you will acquire that will separate you from the crowd. Okay. With that note, guys, please don't forget to press the like button if you like this video. I'll see you all in the next video. Wherever you are, stay safe and take care.